As we discuss functions, it's important to talk about domain and range. These are important vocabulary terms that we use to describe the inputs and outputs of a function. The domain is the set of all inputs, often associated with the x values, and the range is the set of all outputs, often associated with the y values. And I say often because when we graph a function, typically we're graphing it on the x and y coordinate plane, and we think of the x value as the independent variable and the y value as being the dependent variable. And we say dependent because it depends on what we plug into the function for x. So the output value is dependent on what we stick into the function as an input value. Also, if the x value of an input corresponds to the y value output, that output value is also called f of x, right? If the name of our function is f, right? So it's a function of the input x. Okay, so let's try some examples to get familiar with this concept of inputs and outputs. For each one of these examples, we're going to state in words the inputs and outputs, which basically means that we're stating the domain and range in words. And then I also want to state the domain and range in a numerical way. All right. So for the first function, we've got a verbal description. Let I be the function that converts feet to inches. Now, in this function, if we're converting feet to inches, that means we're starting with feet, right? And the output of the function would then be inches. So if we're starting with the feet, that is our input, yes? And then our output would be inches. Now, we haven't been given a formula for this. We could come up with one, right, since it's a pretty simple conversion from feet to inches. But just thinking about the concept of it. Feet and inches are units of distance, right, which we generally accept to be positive. So we might assume, well, okay, the acceptable outputs would probably be from 0 to infinity. So I could write for the domain, we have the interval from 0 to infinity. And then for the range, similar thing, right? We could say 0 to infinity for the range too, because the inches, with that same reasoning, right, that it's a unit of distance. Okay, so now with this next example, we have temperature readings for Portland, Oregon on October 10th, 2012, given in Table 1. Let f of t be temperature in degrees Fahrenheit, and let t be hours after midnight. Okay, so in our table we have this row of t values, which is hours after midnight, and then f of t being the temperature in degrees Fahrenheit. All right, so the input value here are the t values, right? And the output would be the f of t. So we're not using x in this case, but t is definitely our input variable, right? Or the independent variable. And so in Word, the inputs would be t, or the hours after midnight. Okay, and then the outputs would be the temperature in degrees Fahrenheit. Okay, and if we think about that, not just verbally, but if we think about it in terms of the numbers associated with that, the inputs, that carries all of the values that are listed there for t, right? And it looks like numbers 1 through 12. Okay, now when you're given a table of values, don't try to extrapolate what's happening at 2.5 hours or anything like that. We only know the data that's listed in the table. So that's what we'll list. Since we can only include certain values, I'm going to put those values in set brackets. So, and just list them inside the set. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that would be the domain. And then based off of this table, the range would be the temperature values, right? And what are those? So notice that some of these temperature values appear more than once, right? But we only need to list them once in the set. So let's see, the lowest value it looks to be 45, and then we've got 46, 47, 48, 49. Is there a 50? I don't see a 50. And then we have 51. I think that takes care of all of them, right? So like I said, there's no need to list them multiple times. There's no need to list the same number multiple times. But just make sure that it's included as part of the range. Now we've got another example that's just giving us a formula, right? It doesn't give us any real-world context or anything. It just says the function f, where f of x is negative 7x plus 3. All right, so hopefully most of you will recognize this as being linear, right, of the form mx plus b. I wouldn't even need to go to the graph to know that it's linear. And the question then becomes, with the inputs, well, we know with f of x is equal to something, the input is x, right, and the output is f of x, right? So the question then in my head is, well, is there anything that limits the domain? Like in the case of negative 7x plus 3, is there any value for x that would either cause the function to be undefined or that would just not allow us to have a real number for the output? And the answer is no. It could be anything, right? So I'm going to list the domain as all real numbers, right? And we'll list it in interval notation as the interval from negative infinity to infinity. Okay. Now, same with the output, right? If we can put any input in there for x, the y values in this case, graphically, they extend in both directions in terms of y values, right? So negative infinity to infinity would be the range. Okay, so in this next example, the function that we're given is a set of ordered pairs. Okay, so these are the points 5, 4, 3, 6, negative 2, 1, 7, 4, and 1, negative 5. All right, so the inputs, I'm just going to say verbally, they would be the x values of these points, right? And the outputs would be the y values. And again, we just have some specific values, so I'm just going to list them in a set. So you don't have to list them in order, but I think it's nice if you do. So I'm going to have, let's see, the x values there. The lowest x value I have is negative 2, and then 1, 3, 5, and 7, right? And then the range values are the y values, right? What's the lowest y value in the function? Well, negative 5, and then negative 2, 3, 5, and 7. Okay, so hopefully this gives you a feel for thinking about the domain and range as the set of inputs and the set of outputs respectively.